Morning, all CBI students. So this is just a short video to give you a bit of perspective in terms of what we'll be doing in CBI 310. You'll meet me on Monday. I'm William, and I'm your course leader. So, let's get right into it. Have a look at these elements, carbon, hydrogen, oxygen, nitrogen, phosphorus. And we use this M as there's a lot of other minerals that we just put together in one bag. Think of magnesium, potassium, whatever. We group it together and we have this pseudo element called M. Now, if you have a look at these 6 elements, and we include sunshine, so that's the 7th element, that's light, that's the energy source. We are going to be following these elements through all its various combinations it makes. So, have a look down here. I've got a 3-dimensional DNA molecule. You can see the carbons, the hydrogen, the oxygen, the nitrogen. So it's amazing that the complex molecule that stores all the information about who you are, it's really just a fancy combination of carbon, hydrogen, oxygen, nitrogen, phosphorus, and minerals. And in this course, we are going to be following these important atoms, see what kind of combinations they make, and we're going to be looking at how nature designed, nature's the big teacher over 4 billion years. It has taken these Lego building blocks and it has created amazing structures. We're going to be following them to understand a little bit more about life in terms of how we need food, what are the chemicals we actually eat, and how do we produce food, and then what do we do with the food waste, and how do we get fertilizer to grow more food. That is, in a sense, the essence of this course. So following and quantifying atom flows in the natural world. Start thinking about that. So it is quite amazing if you have a look at what life entails. It's really just chemistry. And if you take these 6 elements, it's amazing to follow them and see how they basically constitute all of life. You have the carbon dioxide in the atmosphere, the water, the oxygen, the nitrogen, and the soil. You have different forms of nitrogen. You have your minerals and you have your phosphates. And putting these together, it all boils down to this complex carbohydrate. So you have a complex carbon molecule. It's not a carbohydrate. That was a mistake. That is a combination of different fractions of these elements. And these complex molecules are really the essence of life, whether it's a protein, whether it's a DNA molecule, whether it's food, whether it's carbohydrates, whatever. But really, if we have a look at all living matter, it's just a different composition of these elements. So life is really the constant rearrangement of these elements using the sun energy to drive the whole process. And it's constantly rearranging itself and taking on different forms. In the end, nature is the big recycler. So it always goes in a cycle. What gets used comes back. And we'll be using the whole recycle principle from nature to look at sustainability in our own human life. So in chapter 1 and 2, we're going to start looking at humans and the human diet, the amount of energy we need. If we're going to show if you use too much energy, you get fat. But it's very interesting. We in a sense will be modeling the human as a vessel, because if we have these glasses on of just looking at the elements coming in, we've got, all these elements coming in through our food and our water that we consume. And then it's basically like these elements, they do form different molecules. But the interesting part is if you, for example, have a look at a carbon atom, if you think of a carbon atom in your own body, you can't claim that carbon atom to be yours. So I can't say, hey, in here, let's say my liver, there's a carbon atom and that carbon atom belongs to me. Because if you have a look at the atom flux through the human body, most of these atoms will only spend a few months, maybe a year or so in the body, and then it will disappear. So none of these elements are actually you. And that makes you think, what is a human? I'm just this flux of elements. I can't even own these elements. They come into me, they form, they disappear, they go out of me as I breathe out, as I excrete. So think of the human as just almost like a reactor vessel, containing some elements at certain times, and each element will have a different residence time in the body. Okay. And then we're going to go in chapter 3, we're going to start thinking about food, looking at food, and then we're going to start modeling, using elemental modeling, how plants produce, how our plants produce themselves. So we have to look at the autotrophs, we're going into photosynthesis, and we're actually going to model it as a chemical process, how the minerals from the soil and the CO2 from the air and oxygen is a product, of course, from photosynthesis, is the basic process where we grow all food. Whether you're a vegetarian or a carnivore, you got to start with the autotrophs where you capture the sunlight and actually contain the energy within chemical bonds where humans can eat it to get their energy. And then in chapter 4, we'll be looking at livestock. We'll specifically look at chickens. So if you say, I'm not a vegetarian, I don't just want to eat vegetables, then you got to take the vegetables or the plants that you've grown, feed it to an animal, and then grow that animal and then feed off that animal. We're going to be looking at this whole process also from a chemical modeling perspective. And then we're going to say, if I rather opt for eating meat and I produce plants to produce meat, how much more area of land do I require if I go for a meat eating diet? Then, of course, this course is called bioreaction engineering. A human body is, of course, a bioreactor. You can almost see a plant as a bioreactor as well. Similar, a chicken will be a sense of bioreactor, but then we're going to get more to conventional reactors where we define the vessel and we feed into it also just different compositions of these 6 elements. We'll always be working with carbon, hydrogen, oxygen, nitrogen, phosphorus, and that mineral pseudo component. So, for example, in chapter 5 to 9, sometimes it'll be oxygen, sometimes it'll be in the absence of oxygen, but in a sense very similar to that human vessel. Now it's just a human constructed vessel, but we'll see what comes in. And then it's a living vessel because we'll have microbes, bacteria, archaea, that will be converting or rearranging, basically just rearranging the molecules in which these elements combine. Why do we rearrange? The bacteria rearrange to get energy. It's all about that sunlight initially getting into the plant, getting captured as chemical energy, and then as we eat it, we release some of this energy. As we put, for example, our waste in an anaerobic digester, those microbes are able to get a bit of energy for themselves. It's all about energy. It's a fight for energy, and we'll be using that principle, a principle of nature, to show how we can process waste streams and introduce recycle. So, at the end of the course, when we start getting a bigger picture of how these elements distribute themselves, form molecules, decompose, get into different forms, we'll get closer to understanding how nature works with recycle. And of course, this course has a big sustainability component. We want to teach you stuff that you will use to save this this poor planet of ours, which is at this stage severely harmed by us humans. And the principles from nature is really the principles that we must follow in all our processes. So understanding elemental recycle and understanding how to apply it in the design of the food cycle for humans, that'll be an important aspect of this course. So I'll meet you on Monday. Have fun for your last weekend of holiday. It is going to be a course, hopefully, that you enjoy a lot. See you on Monday.